Hello everyone, I am back with a new video today, and this video is very important because one of the most important part of the subject chemistry is organic chemistry. And you know already that in any competitive examination, organic chemistry plays the, I believe, plays the biggest role. So with the thought of understanding organic chemistry, our first job is to understand how an organic compound is actually represented, because it is not like just writing a simple compound. It's all about constructing a structure. Here bond length matters, here bond angle matters, here bond energy matters. All those things matter. That's why what I have seen that many students actually are very weak in understanding the basics of the structure of organic compounds. That's why I would like to present this video so that it can be helpful to many students who are just starting organic chemistry, or may have started but not understood the basic representation, the fundamental representation of the organic compounds. I do believe that this is going to be a great video, and most importantly, a great helpful video for all of my beloved students. So, how can we name today's class? So, structural elucidation. Structural elucidation of organic compounds. I repeat, it is the structural elucidation of organic compounds. First of all, if I start with the most the easiest one, the easiest compound of the organic chemistry, that is the methane. So this is your methane, CH4. So you are holding the carbon atom here. This is one hydrogen, this is another hydrogen, this is another hydrogen, this is another hydrogen. I believe you understand this. Now, what generally you study in chemical bonding, mostly, if I just talk about CH4, that this carbon atom is sp3 hybridized. It has a tetrahedral geometry, and the bond angles are 109 degree 28 minute, and that can well be understood by PSCPR theory, that in this structure the repulsion force is minimum if that bond angle is maintained. So this is a tetrahedral geometry. But the most important in this structure is to understand how these bonds are represented. To understand how these bonds are represented, let me explain that. So once you are holding this carbon, just see that this bond and this bond, if I consider them to be on the plane, that means, think about it, this is my palm. If I consider this to be a plane, and if I pass this plane through this, so this will cut this will cut this carbon, this will cut this bond, and it will come down. Understandable? So it will cut this, it will cut this one, it will cut the carbon, and it will come down. It is not going to harm this one or this one. Making sense? So if I consider that these two bonds are on the plane, that means this bond is coming outside the plane. A very fundamental concept I am going to discuss in this video. Let me be very clear. No complexity. but you have to understand these basics. So this bond is coming towards you. Think about it. This is going towards you. So that means this is above the plane towards the viewer, and this one is behind the plane. The plane is here. So if I just put the plane in this way, that means this bond is coming behind the plane, and you are not able to see that because this is directed towards the whiteboard and not towards you. So frankly speaking, if I consider types of bonds, so there are three types of bonds in fact. Number one, those bonds or these two bonds which are on the plane, this bond which is above the plane, or we can say which is away from the plane but towards the viewer, and this is also away from the plane but it is away from the viewer also. This one is behind the plane, actually most appropriate term to understand. Clear? Suppose this one I have to represent here. So how would I represent it? So I will put one hydrogen at this position. I will put one hydrogen at this position. I will put one hydrogen at this position. Now here comes the most important understandable fact. And I will put one hydrogen at this position. Think about it, what I am saying. So that means these normal bonds. Now, can you understand what is a human error? Like this bond has become this much long and this one has become so short. Don't take these points in consideration. Okay, that is a simple drawing error. So I can just elongate it. That doesn't matter. Don't look at those points which are not very much relevant. And wherever there will be some error like that, I will myself tell you that this has happened. But that is not the matter of concern here. What is the most important matter of concern is that this compound is being represented by this. Think about it. I believe this is well represented. So this carbon is having this hydrogen here, this hydrogen this side, this hydrogen is coming towards you, and this hydrogen is going away from you behind the plane. So these bonds are called the normal bonds on the plane. So I can call these bonds as the normal bonds. So why we are calling it as normal bond? Because we are representing normally. We are representing this normally. This one is called as solid wedge. You understand? Wedge. Like from the board, if I try to fix a nail here, if we fix a wedge here like this, so it is coming towards you. See, look at this face. And if I put this in this way, away from the or behind the board, that means it will be outside this plane. Therefore, you will not be able to see that. But if I make it in this way, so it will be coming towards you, as if it is trying to hit you, isn't it? So this is solid wedge, and this one which is going behind the plane, my dear students, it is called dashed wedge. Clear? So now do you understand that apart from this sp3, apart from this bond angle, apart from this understanding the overlapping between the orbitals of carbon and hydrogen, we do have some more thing to understand. And that is which bond is actually which bond is actually represented in this three-dimensional representation. In this three-dimensional representation, and it's like the compound is flying. You know, three-dimensional structure. You have gone to a movie theater to watch a 3D movie. You wear a 3D spec, and by that you can see that everything is flying. But that is not possible in case of two-dimensional one. So in three-dimensional one, the things are flying. If you have seen any good movie in a theater where it is a 3D movie and you wear a 3D spec. So this 3D representation is basically known to be a flying wedge model. You do have this idea? So it is called a flying wedge model. Like the wedges are flying. It's flying like a butterfly. It's flying like a free bird. It's flying. But you know what? with a flying object, we can't make a reaction in chemistry. An object is flying and we are going to make a reaction by throwing some chemicals on it. Okay, jokes apart, the main important thing is the most important representation which is convenient for us. Definitely we can work with this also, but the most important one which is very much convenient that we can work with, that is the 2D representation. So generally we have the duty, we have the responsibility to convert this 3D structure into a 2D one. So when this 3D is getting converted to a 2D representation, that 2D representation, my dear students, is known as the Fischer projection, named after the eminent chemist Emil Fischer. So that is called the Fischer projection. I will come to that matter in this video only, but just let me be clear whether I have been able to make you people understand about it. Always your comment in the comment box as per the section is always very much desired. I die for getting your valuable comment. Now, if I change this carbon, I mean, have you seen that here with the carbon, all the atoms or groups, like here the atoms were there, hydrogen atoms, they are the same type of atoms. But what if we just connect with it some different types of groups? Clear? So remember, at this point, the things are same. You have a normal bond here, you have a normal bond here, you have a solid wedge here, you have a dashed wedge here. And you know, this carbon at this particular moment is known as the chiral center. Chiral center. What is a chiral center? Suppose with a carbon, if all four different groups are connected, like W, X, Y, Z, where W not equal to X, not equal to Y, not equal to Z, that is a chiral center. So this is a chiral center. Now, you will definitely ask me, sir, what is a chiral center? I mean, you use a term, those who are the first time viewer will not be able to understand. So I would request you, for now, you don't tax your brain much into understanding what is chiral center or what is chirality. In the upcoming videos, definitely I will talk about it. It is based on the stereochemistry, or it is based on the stereoisomerism part, optical activity, which is not a concern of this video. But just to make you people understand, I should tell you that anytime if you get a representation like this, where the carbon atom is connected with all the four different groups, my dear students, then that is called as chiral center. So this is a chiral center. Fair enough? So, in this compound, you can find there is only one carbon atom, and therefore this is the single chiral center. So I can say that this is a compound with single chiral center. इसमें एक ही कार्बन है और एक कार्बन जो है वो chiral center वाला है, यानी कि उसके साथ चारों ग्रुप डिफरेंट है. If I rub it and if I put here OH, my God, this is now not a chiral center. Clear? So all the four groups should be different. Clear? Now, there may be a compound which is having more than one chiral center, sir. Yes, of course. Think about it. If I consider this carbon, so for this carbon, try to understand. These concepts will be used in my upcoming videos. So those who are watching this, you have to watch continuously, serially. That means this carbon, it is connected with this yellow ball. I'm not talking about any atom group now. Let us talk about the ball only. So this is the yellow ball. This is the green ball. This is the red ball. So already three different. And this whole thing is also a different group. It's a bulkier one. It's a bulkier one than this, but it's a different one. Making sense? Understandable part of this? So this carbon is having all four different groups or atoms. better to say groups, because this may not be a single atom, it is a group of atoms. So this time this is a chiral center, as well as this carbon is also a chiral center. Why? Because this is holding this green ball, this is yellow ball, this is the orange or red, whatever you say, that ball. And again for this also we have this group of atoms, this aggregation of the atoms are also connected with this carbon. Making sense? So this one is highly important, that here this compound is having two chiral centers. How many chiral centers? Two. I repeat, how many chiral centers? Two. So it's a compound which is having two chiral centers together. Now, if we think about the representation of this compound, suppose if I just represent this also, anything possible. So if I represent this, so can you see, we have a carbon, we have a white ball. I am not giving any name, okay? White ball. This side yellow. Can you see this is yellow? This is the red one is towards you. So this is your red. Always, anytime you have a confusion, pause the video, repeat it, rewind it, and again check, continuously check it. And you have, with a dashed way, you have the green ball. So now we are coming to the main issue of this video. So this is a three-dimensional model. This is a flying wedge model. In this case, we can see that this is the normal, the plane is coming towards this. That means this is the normal bond. It is, the plane is cutting this, the plane is cutting this, the plane is cutting this. And this is coming towards you. This is going behind the plane, away from you. Now, my job is to represent this into a two-dimensional figure. It's a flying wedge model, three-dimensional flying wedge model. So see what I am doing. According to Fisher, you have to do what you know. Right now you have three types of bonds. Normal, towards the plane, away from the plane. Now you are instructed to convert the structure into such structure which will have only two types of bonds. One behind the plane, another one above the plane towards you. Clear? Right now it is three types. That means the normal bonds are also there on the plane. But Mr. Fisher is telling that you should convert into a such structure where you do not have the three types of bonds and you do have only two types. One type will be towards you and the another type will be behind the plane, away from you. Making sense? Now, if I am holding this, how can I do that? If I am holding this, so I will just convert it in this way. Look at the rotation. I am holding this in this way and I am just converting it into this way. So my rotation is like this. So what happened in this? Now, if I consider this to be my perm, the perm comes here, cut the carbon and then goes away. It is neither cutting this nor cutting this because all of them are away from the plane. It is towards you and it is away from you, but they are away from the plane also. No one of them is on the plane. So the plane is going like this, cutting this and coming down. Making sense? At this moment, we can represent this. Can you think about it? We are taking a shadow of this. So how does it look? It looks like this is W. It has become behind the plane. Y also behind the plane. R is in which side? Think about it. It was like this. Please understand, this is a very simple video. You can pause it and again check it again and again. So I have just converted it in this way. That means this red ball is now coming towards this side. Clear? And the green ball obviously coming to this side. So now we have converted the 3D into a format which is about to produce a normal 2D structure. So just it is like holding this, and if we are taking a shadow. So now if I represent this normally, so carbon is here, W will be this side, Y will be this side, R will be this side, and G will be this side. So my dear students, this is a simple 2D representation of this 3D representation, and this is the Fisher projection of the given compound. Every year you get some questions based on this. This is a very simple description now. Once we will convert it into a, we will take a 2 chiral center, 3 chiral centers, and we will convert it into a 2-dimensional picture, and we will try to figure out what are the relations between the structures, enantiomers, diastereomers, homomers, all those things. This is going to be very, very important for the competitive examination. Now, let me tell you that we can also have this representation in this format also. Like I am holding this, okay, I am holding this. So this normal bond can be in this side also. So I can say, if I have a carbon here, if I have a W here, if I have a green ball here, so I have a red ball this side too, and I have yellow ball this side too. So at this moment what we will do, we will rotate it in this way. I will hold it and I will rotate it in this way. In that case also, see, this white ball and the green ball is going behind the plane, and the red and the yellow both are coming towards you. Think about it. They are coming towards you. So what I am having here, please again understand this. So if this is in this side, so I am holding it and again I am rotating in this side. That means this carbon is here. The white ball goes behind the plane. The green, see the green here, down, going away from you, behind the plane. So the green is also at this position. The yellow one is in this position. The yellow has come in the right hand side. From your side is in the right hand side, yes or no? And the red one has come in the left hand side. Making sense? I do believe that you have understood this. Now, this one, if I put the simple representation, so it is W, it is G, it is Y, it is R. Making sense? So even in this format, if your single chiral center containing compound is present, please understand, for two chiral center containing compound, we have a different strategy. But for this, what we are going to have is for the single chiral center. So if it is present in this way, we will represent it into this format. Now, if you have understood the concept properly, if you have understood the total concept properly, here also I just want to tell you that you don't consider this length and this length and this length and this length. Okay, these are normal just for the representation. So now let me tell you what. So we do not have the model. We do not have we do not have the time to calculate it in the examination hall. So do you provide some shortcut? Yes, I do. So what is the shortcut here? Just try to understand. Suppose you have the carbon, you have NH2 here, you have SH here. I'm just taking as an example. You have chlorine this side, you have bromine this side. Okay, understandable? So always if you have like this structure, you know what you have to do. Put the normal bonds above and below the carbon. So carbon to right, NH2 goes up, SH comes down. Now follow this tapered bond. It's like an oblique bond, it's a tapered bond. So the tapered bond is directed towards which direction? If I take a look from this side. So if I am taking a look from this side, I can find that this SH group is directed in the right hand side direction from my point of view, if the viewer is like this. So this SH is in the right hand side. So please do understand that this solid bond will always be in the right hand side. That means the Cl will be here. So obviously the bromine will be here. It's done. I hope you like the trick. In a similar manner, if you are having, suppose if I am taking a structure like this, yes, so now this is the representation, but you can see here easily that this normal bonds, and out of the normal bond, this bond is the taper bond. It is in the left hand side from our point of view. It's from your side also and my side also, because we are looking to the board only. So it is in the left hand side. So you have to do what, you just keep the carbon here, put OH in the side, put CH3 over here, keep your Cl towards the left hand side, keep your I towards the right hand side. Why, sir? It's because, my dear students, that I told you when this normal bond will be in the right hand side, you keep the solid wedge in the right hand side. In the similar manner, when this normal bond is in the left hand side, you keep the solid wedge in the left hand side. So this is the representation of this structure. Is it clear to all of you? You are free to see this. So what I so far discussed is basically the very, 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 very fundamental structural elucidation and structural representation, where we had a three-dimensional structure like this, which is having only one chiral center, but it can have more than one carbon. Like this group can be CH3, this group can be C2H5, this group can be C3H7. Anything is possible, but I'm saying the chiral center will be only one, like this one. So for that carbon, so for that compound which is containing one chiral center, what is the definition of chiral center? I have discussed about it. We have this strategy to be followed while we are converting this three-dimensional representation into a two-dimensional representation, that is from the flying wedge model to a Fischer projection. I do believe that you have understood the concept of this. I would not like to elongate this video, because it is better to split the concepts and then to give you. You will have patience to watch it, and then you will wait for the next video, and definitely I will upload that as soon as possible. Till then, I can request you very humbly, please watch this video again and again, just to clear your concept completely. It should be crystal clear, so that in the next videos, when we are going to discuss the topics which are little bit complex, more complex than this, will have some more complexity than this, you should understand that. Because if you are not understanding A, B, C, D, it's really not possible for you to understand a complete paragraph or even a complete statement. Thank you very much, all of you, my dear lovely students out there. Be safe, and again, you know that it's a humble request. If you like the video, please, if you like this video inherently, then please like the video physically by pressing the like button and subscribe the channel. Also, definitely, as you know, all the YouTubers say that press the bell icon also, so that you can get a notification whenever the videos come. And on which topic you people want some videos, definitely let me know in the comment section. I would definitely try to upload it. Thank you very much. Thank you.